Melia Science.
Why is it so cold?
Why is it so cold? Because this is the way.
Why are the plants dead?
Why are those plants dead? Because that is the way.
Why is there so much snow?
Why is there so much snow? Because that is the way.
Those are very good answers.
What do you mean those aren't very good answers? Okay, you're right. They don't explain much scientifically. It's the way of the cycle. Everything happens in cycles. Let's go on inside and I'll show you exactly why all these things happen and why it's because of cycles. Oh no! He's eating snow. I bet he thinks that snow's clean. But guess what, kid? The snow's not clean. It isn't. And we're gonna prove it to you. Watch this. Hold on to him. Don't let him eat any more snow. Look at this nice clean snow he's eating. We're gonna get some of that and we're gonna show you that this snow
It's not clean.
is not clean. All right, let's go in and explore cycles. This is the way. Okay, that was a lot of questions. And we have a new helper here today. What's your name, helper?
Parker.
Parker. So, Radical Roland couldn't be with us today, so we have Powerful Parker gonna help us with our science video today. All right, now, some of those questions you were asking out there were like, well, why is there so much snow on the ground? How come it's so cold? How come all those plants were dead? Well, the answer to all of those is because of a cycle. And we're gonna look at different cycles. Cycles are all around us. They're just patterns in nature that repeat themselves. So, and there's many different types of cycles. There's the water cycle, the rock cycle, the sun, the cycle of the seasons. And that's the answer to one of your first questions. Why is it so cold out there? Well, because of the cycle of the seasons. Now, let's just pretend, if we move this out of the way, and you stand right here, let's pretend that you're the sun. Parker the sun. All right? And I'm going to give you a sun to hold. Here we go. Now, in real life, the sun is much, much, much larger than the earth. But it's far away, so it doesn't look very big. So, Parker's the sun. And the earth travels around the sun. It travels around the sun. Now, what makes it cold is right here is where we live. Right there. You see that? North America, right by Lake Erie. That's where we live. Now, sometimes we are tilted away from Parker the sun, and that's when it's cold. Sometimes we are tilted right at Parker the sun, and her sun rays are hitting us perfectly, and that's when it's warm. And sometimes we're straight up. So this also gives us the seasons. When we are tilted right at Parker the sun and getting all her warm rays, then we are in the summer. If we are tilted away, like right now, then we are like not getting a lot of Parker's warm sun rays, and we are in winter. And sometimes we get a medium amount of sun rays, and that gives us spring and fall. So that is the cycle of the seasons. From summer to fall, winter to spring. And that's the cycle of the seasons. The sun is also part of our water cycle. Okay? Yeah, the sun is also part of our water cycle. We have water on our earth, H2O. And it exists in three forms. It exists in ice, snow, a solid form, a liquid form, water, and a gas form, water vapor. And it changes back and forth between all those forms. Now, with this model, we're going to show you how that happens. And this is how the same water that we drink and the same water that's in the snow out there is the same water that the dinosaurs drank. It's just going through a cycle. All right, so we're going to set this up for you. Okay, Parker, we are going to look at the water cycle now. In here, I have a model of some terrain, right? It's just a mountainside that goes down to a flat surface. Now, right now I got some water in here. It's a little bit of warm water, not too hot, but if I add this cover, that warm water is starting to evaporate. If I add this cover, and I'm gonna add some ice up here, and that's gonna make the air colder. The air colder at the top, just like our planet. Now already we can see what's starting to happen. The water, the warm water is evaporating, and it's then condensating on the roof of this model. It's evaporating because it's warm and it's jumping up into the air, but then it's condensating. It's forming these little tiny droplets. And you know, if we put our finger in there, we could like write on them. Now what's gonna happen is, see, they're turning into water vapor because of the water on the bottom is warm and it's jumping up into the air. But because we put ice up here, it's cool. It's cooling the air, or it's cooling the water droplets, and they're coming back together. This is called evaporation when it goes into the air and becomes a gas, evaporation, and then condensation when it comes back together and forms droplets. And if we watch this for a while, we're gonna notice that the water is gonna start dropping back down. We'll see up here how it's looking. Oh, I see some droplets forming. There's some droplets forming in there. Not yet, but if we give it a little time, it's gonna form. And then what's gonna happen is, that's right, it's gonna fall onto those mountains and make its way back down to the water level, to sea level, what we would call it. It's gonna make it back down to the big pool of water. We'll call it Lake Parker. And that's the water cycle. And then it's gonna evaporate again, go back up into the air where it's cold. The higher we get, the colder it gets, right? That's why when you see the tops of mountains, they're all covered in snow and ice. It's because it's cold up there, very high. So the higher we get, the colder we get. So again, it's a cycle. The water, it doesn't matter where you start really, but here we'll start in Lake Parker. The water evaporates into the air. And then when it gets to the cold air, caused by our ice, but in real life it's just caused by the cold air that is up high in the sky, it begins to cool down and it condensates. It condensates, which means it comes back together and it forms droplets. And when these droplets get big enough, they precipitate, which means they fall down as rain or snow. Yeah, there you go. Show them how they fall. They fall down as rain or snow. And we're gonna come back to this in a minute after we let the water condensate a little bit, but we gotta talk to the child. I guess we know his name now. What's his name?
Grogu.
Grogu? All right, Grogu. You were trying to eat snow, and I see a lot of kids out there eating snow because they think, oh, snow is so white, it looks clean. But did you know that in order for a snowflake to form or a crystal to form, it forms around a piece of dust or dirt that's in the air? Right. You don't see it because it's too small and it's hidden behind all those beautiful, beautiful snowflakes. You would eat this snow? Yes or no? Would you eat this snow, Grogu? Yes, he said he would. Well, let's go melt it and see what happens. I'm gonna put it under some warm water. And we're gonna heat it up. Remember, that's how we change things from one state to the next. We add or take away heat. Oh yeah, there we go. You could just let it sit, but why do that? Could put it in the microwave, that would be fastest. Hey, that snow that you were drinking or eating, obviously I noticed it takes up a lot less space, doesn't it? When it turns to a water form. It's not even very filled up at all because the snow was crystallized. It was in crystals where the water is just taking the shape of its container. All right, let's look at this, Grogu. You were drinking the water, but let's look inside that water. Look at all that, shake it up. Yeah, look at all that dirt and stuff in the water. I'm gonna put it against the whiteboard so we can see a little bit better. That is all the dirt and guck that you eat when you eat snow. And that snow looked really clean too, didn't it? So, Grogu, would you drink this water? You would? Look at all that guck in there. Well, maybe you would. Powerful Parker, would you drink that water? No. Look at that. You think it looks clean, even if you avoid the yellow snow. Ew.
No, and the pink snow.
You have pink snow? What? Okay, now let's go back to our water cycle once more. Now, a lot of that has gotten a chance to heat up. And when we lift this up, you can see up there, there's all the little water droplets forming. Whoops. All the little water droplets are forming up here that will fall to the ground. And when they fall on those mountains, and they make their way all the way back down. We go like this, causes a little bit of rain. We're helping them build up a little bit more. And that's the water cycle. The water evaporates, evaporation, and then it condensates, condensation, and then it falls, precipitation, and it falls depending on the weather and the temperature. It falls as snow or rain or sleet, and then runoff is the other part. Is when it runs down the mountain or under the mountain, even underground, and makes it all the way back to the lake where it evaporates, and then it condensates, and then it precipitates, and then it runs off. And then it evaporates, and then it condensates, and then it precipitates, and then it runs off. So it's a cycle because it repeats itself. Now, Parker, you asked me why there were so many dead plants out there. Well, that's part of another cycle. It's called the life cycle. Everything goes through a life cycle, including plants. Now, plants start off, where we're going to start off, as a seed. The seed goes underground. It gets moisture and the right amount of moisture, and it begins to germinate, which means it breaks out of its seed and starts to grow. And then it pops up out of the ground. Then the young plant gets enough sunlight and nutrients, and it grows into an adult plant. And then the adult plant is pollinated by birds or bats or bees or something like that. And it produces a seed, which falls into the ground or onto the ground. And there's way different ways that we can get these seeds to travel around. That's a whole nother neat thing. But it's a cycle, because then this plant dies, but then this seed that it left behind begins to germinate. It grows into a young plant. It gets enough sunlight and water and nutrients from the soil that it grows into an adult plant. And then it gets pollinated by birds, bats, and bees and produces seeds. The seeds fall to the ground. This plant dies, but then the seed begins to germinate. And then it grows into a young plant. This young plant gets enough sunlight and nutrients and water to grow into an adult plant.
I think that's enough.
Wait, you think so? But it's a cycle. It goes on forever and ever and ever and ever. But you're right. That is enough for now. That is part of the life cycle of plants. And everything has these, every living thing has a life cycle, right? Something that goes around and keeps that species going. And that's why we saw those plants out there that were dead. But those plants, before they died, they produced seeds that are now in the ground waiting for the right temperature to germinate and produce new plants. All right, let's look at one more cycle, and this one rocks. Okay, now we have a bunch of rocks. Rocks also have a cycle. The rock cycle has been around since the time the earth began. It's a very old cycle. And the rock cycle is made up of three main types of rocks. There's lots of different types of rocks, but three main types. First of all, we have sedimentary rock. Sedimentary rock. It's made from little bits of sediment and sand and bits of tiny pebbles and rocks and sediment that other rocks left behind when they got weathered and eroded by water. So this sedimentary rock is made of a bunch of other different types of rocks, and it forms in layers. A lot of times you see layers in them, and they're one of my favorite types of rocks. Do you know why? Because they're the types of rocks that we find fossils in. Yay! Hold on a second. Like this guy here. Look at that. He's a fish fossil that we caught out of, looks like some sandstone. Here is a trilobite that we found in some shale. Both types of sedimentary rock. You can see they come apart in layers. That's one big thing about sedimentary rock. And here's another part of a fish fossil that is caught in some sedimentary rock. Okay, so that's sedimentary rock, my favorite. And we also have igneous rock, all right? Igneous rock would be like this granite. This granite is igneous rock. It's made up of a bunch of different types of rock. I think feldspar, mica, quartz, but it was formed, somehow it got pushed into the ground, and it got pushed to a place like maybe a volcano or a layer of lava where it was formed by fire. Fire formed, igneous, ignite. You ignite a fire. And so this is the next type of rock, the igneous rock, or the metamorphic rock. Now here's another igneous rock, but this rock's kind of cool. He can float on water. This is called pumice. He came out of a volcano. It cooled so fast, it had so many bubbles stuck in it that it could float. And then finally, metamorphic. You know the Mighty Morphin Power Rangers? It means to change. Metamorphic rocks change over time because they're under a lot of heat and pressure. So they change from one of the other rocks to a different type of a rock. And this is quartzite. Quartzite, a metamorphic rock. And the rock cycle goes like this. One of these rocks gets weathered or eroded, and then it turns into sedimentary rock. And then maybe the sedimentary rock gets buried into the ground and makes its way to an underground layer of magma, and it turns into, an igneous rock. And then the igneous rock might come up to the earth, or it might get forced further into the ground, and it stays there under heat and pressure, and that's when it becomes a metamorphic rock. So, and it'll go back and forth. Any type of rock can turn into any of the other types of rocks. It's the rock cycle, and it rocks. I think we learned a lot about cycles today, don't you? All right, remember, a cycle is something that repeats itself, and they're all around us. The sun, earth, moon cycle, the cycle of the seasons, the cycle of the rocks, the water cycle. All these things are different cycles. The life cycle are different cycles that we have around us in our environment. And they're part of our lives. And we live by them, right? We live. When it's cold, we do things differently than when it's summertime. So cycles are very important. All right, guys, we'll see you later. Remember, keep on exploring and keep on doing science. This is the way.